Good morning to one and all. In today's lecture, we'll discuss about the 3-bit ripple down counter using positive edge triggered flip-flop. Now here we are using 3-bit ripple counter. That means we will be using 3 flip-flops. Now it is said we have to draw ripple counter, that is down counter, using the positive edge triggered flip-flop. Means your clock will be positive, so we won't apply a bubble over here. Clear? Now in the previous lecture we used the JK flip-flop. Now here in this lecture we'll draw through T flip-flop. Now here we can see at flip-flop FF0, flip-flop 0, here the input is applied 1 to T0 and here your Q0 is the output. Same is for flip-flop 1 and flip-flop 2. Now we'll see how we'll connect our output Q0 to the second flip-flop. So for that we can see we want a positive edge triggered flip-flop. That means that we have to use 2 negative down counter to get a positive up counter. Positive counter means if we multiply 2 negative terms, then only we'll get positive, and we want the positive flip-flop only. Now here this is how we represent a negative pulse. So we'll connect it to the flip-flop 1, and same at Q1 the output will be connected to the input of flip-flop 2. Clear? Now this is how we draw our ripple counter. Now coming on to the truth table. For the truth table, see we have 3 flip-flops, means we have used 3 flip-flops. So how much possible outcomes it will be? 8 possible outcomes will be there. So we will draw the truth table for the 8 possible outcomes. Now we'll draw, see here I am drawing for your convenience. Suppose this is your clock, Q2, Q1, Q0, Q2 bar, Q1 bar and Q0 bar. Now here see, first if we apply clock pulse as 0, initial state, if we talk about the initial condition, means your clock is 0, so your Q0 will be 0. So the output of Q0 is going at the flip-flop 1, as well as the output of Q1 is going to the flip-flop 2. Now here we will, initially it will be 0. Now if it's 0, we'll see at the output your Q1 will be complement of it, same your Q0 and same as well as your Q2 bar. Now if we apply positive pulse, because we want positive edge trigger, if we apply the positive pulse, so at the flip-flop 0, here, if we have applied, so what was our previous output? 0. It will get complement of it, so we'll complement of it, it is 0, so your Q0 bar will be 0, then Q0 is 1. Now at the second flip-flop, see the transition. The transition is from 1 to 0. When the transition is 1 to 0, it is positive, and when the transition is 0 to 1, it is negative. We know this concept. Now here your Q1 will be 1 and your Q2 will be 1, because we are using the positive edge triggered only. So your Q2 bar will be 0 and your Q1 bar will be complement of it. Now if we apply second positive pulse, now at Q0, we'll see when we apply the second pulse, the previous output was 1, now we'll get the complement of it, that is 0. So it will be, Q0 will be 0, so Q0 bar will be 1. Now here we can see the transition is from 0 to 1. 0 to 1 means it is a negative edge trigger, and in the question, it is in the example it is given, we have to draw the positive edge trigger. So your state remains same, means your output will be same, that is your 1 1, and it will be 0 0. Now if we apply third clock pulse, so our Q0 is 0, we'll get complement of it, that is 1. Now we can see the transition is from 1 to 0. When the transition is from 1 to 0, it will be 0. Clear? When it is 0, see here the transition is from 0 to 1. 0 to 1 means negative edge triggered flip-flop. This is positive edge triggered flip-flop, and we are getting the output, that is the negative. So your output remains same, that is your 1. Clear? Now fourth, here your output at the Q0 will become 0. Clear? Now here the transition is from 0 to 1. When the transition is from 0 to 1, it will get 0. Clear? Now here we see we are getting, and your Q2 will be 1. Clear? So here the output at 101, it will be 0 1 0, and here it will be 0 1 1. Similarly, we will be doing it for when we'll apply the positive pulse at 6, 7, 8 correspondingly. Clear? Now we'll draw the timing diagram of it. So coming on to the timing diagram, here we will see the positive edge triggered only. We will mark the positive edge triggered. So at the output Q0, we will see it will remain same unless and until we don't get the next positive edge triggered. Till then its output remains same. So it will be 1 till over here. After that it will change its state. It will be 0, then 1, then 0, then 1, then 0. Clear? Now for Q1. Q0 will be the act as an output for it. So at Q1 we'll get these are our positive edge triggered. Now here we will see it remains same till the positive edge triggered flip-flop. Next, after then it changes states. That is 1 0 1. Similarly for Q2, we can see this is the positive edge triggered, and we have two positive edge triggered. Now at Q2, output will be dependent on Q1. So here we will get it till here. It will remain same, and after then it changes its state. Clear? So here we can see that this is a time period T, because one cycle completes over here only for the clock pulse. So this is your time period T. For Q0, it will be twice T. This T plus this T, it will be twice 2T. After then it will be 4T, and for Q2 it will be 8T. As we know the relation that F is equals to 1 upon T, where F is your frequency and T is your time period. So we can see over here, as we are applying time period T at Q2, we get a frequency as 1 upon 8T. Clear? So your frequency at Q0 will be 1 upon 2T, 1 upon 4T, and 1 upon 8T. So this was all about your 3-bit ripple counter using positive edge triggered flip-flop. Thank you.